So physics is a really broad subject. In some sense, it is the fundamental science because we are looking at the fundamental rules that govern how the physical world works. There are many, many different branches of physics that people study. Especially in current research, there are dozens or hundreds of subfields that you can specialize in. I wanted to list just a few of these branches of physics and point out which ones we'll be covering in Physics 6 and Physics 7. So in Physics 6, we're starting out with mechanics, which is the study of motion. And for about 2/3 of Physics 6, we will be understanding how to describe motion using all sorts of tools like kinematics, Newton's laws, energy, momentum, angular momentum. So we're going to learn all that stuff that's within this field of mechanics. We'll also talk about thermodynamics, and if you have ever taken chemistry class before, some of this will be familiar to you. Thermodynamics is the study of heat and temperature and energy exchange. We'll discuss waves and sound, sound is kind of an application of waves. Waves are when you have energy that gets transported from one place to another via a disturbance. So these are the Physics 6 topics, the branches of physics we can cover in this class. In Physics 7, we'll be looking at all of these topics. Electricity, magnetism, electromagnetic radiation, otherwise known as light. And I know there's some folks in the class who are studying to become radiologists. This topic will be very useful for you. We'll talk about quantum mechanics, which is like mechanics, but for small stuff, like electrons and atoms. And with an understanding of quantum mechanics, then you can begin to understand atomic physics, which tells you how atoms behave, where the periodic table comes from, some of the basics of chemistry. In some sense, chemistry is kind of applied atomic physics. Then there's nuclear physics, which is how the nucleus of an atom works. And in Physics 7, we'll also discuss optics, lenses and mirrors and so on. So these are kind of the topics that a typical university introductory physics class covers. But of course, there's all these other subfields, and here are just a few of them. There's particle physics, where people study the fundamental building blocks of nature. What's even smaller than a proton or a neutron? Well, it's quarks. Where do forces come from? Well, they're force carrier particles. And particle physics is the field where you get to use giant particle accelerators, the biggest science experiments in the world, like the LHC at CERN in Switzerland. Solid state physics, study of solid materials. This is particularly useful for electronics applications, developing microchips and so on. Materials physics, how to make materials that are stronger or have better electronic properties. Low temperature physics, interesting stuff happens when things get really cold. Astrophysics, how do stars work? Cosmology, how does the universe work? What's the origin of the universe? Biophysics, what's the physics of biological organisms? Physics of cells. And medical physics, there's all sorts of medical devices that you can build. And again, radiology is an application here. Physics comes in really handy in medical diagnostics. So these are just a few of the branches of physics. Physics is an enormous subject, and we're going to give you this base of fundamentals during this year, and hopefully you can apply these fundamentals to your particular field, whether it's radiology, where this really comes in handy, or maybe you're doing physical therapy or kinesiology. In that case, mechanics is going to come in handy. So we'll give you a strong base of physics throughout this year. and I hope you enjoy.